All right, we're into the practice video. I do recommend that you try each of these problems on your own before you check the answer, but that's up to you how you kind of want to roll it. So we're going to multiply with scientific notation. So remember, when you're doing that, you multiply the non-power of 10 numbers first. So 3.2 times 1.5 yields 4.8. When I'm multiplying my powers of 10, if I multiply, I add the exponent. So negative 5 plus 3 gives me a negative 2. So in scientific notation, I am 4 8/10 times 10 to the negative second. Now I'm going to divide. I often believe that dividing in scientific notation is easier if I start vertically. So I'm going to rewrite my problem vertically. I'm going to divide the first two numbers. Since they are both two significant figures, I'm going to go ahead and round that to 2. So I'm at 0.454. I'm going to subtract my exponents. So negative 2 minus 4 yields a negative 6. Now hopefully you say that is not in scientific notation. This here is less than 1. Less than 1 is small. If I'm going to move this one place, this is the same as 5.4 times 10 to the negative first. Well, I still have got to bring down this times 10 to the negative sixth. So now when I put these two together, I'm multiplying, same base. I add the exponents. So my final answer here in green is 5.4 times 10 to the negative seventh. Let's go ahead and do another one of these. We're going to divide. This time we are not going to end up with a small front figure. 2.57 divided by 1.3 yields 1.98. Now I'm going to subtract my exponents. 6 minus a negative 8. Remember, two negatives is a positive, and so I end up with times 10 to the 14th. Key there is adding the opposite. Now let's get into some story problems. The sun is dying. Scientists estimate the sun has only 5 billion years of life left. Should we be worried? Well, if we round the human lifetime to 100 years, how many human lifetimes does the sun have left? So we're taking the sun's life divided by the human life to see how many times we have. So the sun is 5 billion. Human lifetime is 100. Let's change those both to scientific notation. Billion is 9, so that's 5 times 10 to the 9th. Move that two places. This is 1 times 10 to the second. So if I divide my front numbers, 5 divided by 1 is 5. Subtract my exponents, and I'm at 5 times 10 to the 7th, which means 1, 2, 3, 4, 5, 6, 7 zeros. We're talking 50 million human lifetimes. I'm not worried. I'll be long dead by then. Number 5. The mass of the Earth is about 6 times 10 to the 21st metric tons, and the mass of the Sun is about 1.998 times 10 to the 27th metric tons. About how many times more is the mass of the Sun compared to the mass of the Earth? Now, this one is a little bit hard to understand, but this is what it's saying. The Sun is the Earth times what number? That's what they're saying. How many times do you have to multiply the Earth to get the Sun? Now, algebraically, if we would divide both sides by the Earth, that would give us our unknown value is the Sun divided by the Earth. So that's what we want to do. We want to take the Sun, which is 1.998 times 10 to the 27th, and we want to divide by the Earth, which is 6 times 10 to the 21st. So I divide my front numbers, and I get roughly 0.333. And I subtract my exponents, so I get times 10 to the 6th. Now, when they're asking how many times, we generally don't talk in scientific notation. So I want to take this 6, and I'm going to move it 6 places. 1, 2, 3, 4, 5, 6. Those 3 spots give me zeros. So the Sun is 333,000 times larger in terms of mass than the Sun. According to Tootsie.com, there are 64 million Tootsie Rolls produced each day. If they have been steadily producing this amount since the company moved to Chicago in 1968, approximately how many Tootsie Rolls have been produced in Chicago? Okay, so think about this. So each day. There are 365 days in a year. We are now in 2018, which means we're talking 50 years. So if I take 365 times 50, that's how many days they've been producing Tootsie Rolls, and I need to multiply that by 64 million. So this is the basic problem. Now, I don't know about you, but that looks a little bit crazy to me. So what I'm going to do is I'm going to change everything to scientific notation. So I've got 3.65 times 10 to the second. I've got 5 times 10 to the first, right? Moved it one place. Million is times 10 to the sixth, but this has to go over 1. So this is 6.4 times 10 to the seventh, because that 1 would get added to that exponent. Okay, so now I can multiply these three numbers together, which gives me 116.8 times 10 to the, I add my exponents, and I get times 10 to the 10th. Well, remember, this is a big number because it's greater than 10. So I have to move it 2 places, and if I move it 2 places on a big number, my exponent gets bigger. So I end up with 1.168 times 10 to the 12th. And if you recall, 12th means trillion. So they produced 1.168 trillion Tootsie Rolls since 1968. Of course, this is an approximation. Let's get to per capita. The National Oceanic and Atmospheric Administration reported there were 17.8 million feet of Atlantic coastline in the state of North Carolina. If the population of North Carolina is approximately 9.5 million, find the number of feet of coastline per capita. So we're talking about feet of coastline, oops, can't spell, over people. Well, there's 17.8 million feet of coastline, and there are 9.5 million people. Well, the millions will cancel out because they're the same. So I just have this. If I divide, there's 1.87 feet of coastline per person. I don't know about you guys, but I need more than that. That's just not enough. What about in Oregon? In Oregon, there's just over 6 million feet of Pacific coastline, and they have 3.8 million people. So if we take the 6 million, divide it by the 3.8 million, again, the millions cancel out. We just divide. That gives us 1.58 feet of coastline per person. So this question says, compare your answers above. Well, North Carolina was 1.87. Oregon was 1.58. So the difference is roughly 0.29 feet. So North Carolina has 0.29 feet of coastline per person, which is important, more than Oregon. That's what it means, right? Not a ton, but there is some. Now let's get to a table. We want to complete the table by talking about school districts per capita in decimal form here and then scientific notation. Let's do Indiana together, and then I'm going to hit pause so you can do the rest. Okay, so in Indiana, number of school districts per person. Don't forget this population is in million. Million means 6, so I'm going to move this decimal 6 places. So 295, 6.6 million. Or you could change them both to scientific notation. That would work too, right? That would have been 2.95 times 10 to the second over 6.6 times 10 to the sixth. Either way, mathematically, you should get the same thing. When you do that, you end up with 4 zeros, a 447, and then 4.47 times 10 to the negative fifth. That's a 5. Okay, I'm going to hit pause. I want you to do the same. Do the other 3, and then come back and check your answers. Okay, so you see the rest. They're all times 10 to the negative fifth. They all have 4 zeros after the decimal point before you get to the numbers. So the decimal portion is hard to read, right? You have that many decimal points. It's just a little bit difficult to really work with. But when you get to the scientific notation, because they all have the same exponent, you can do a little bit better comparison there. Okay, so now we're going to talk about Indiana. Recall that Indiana per capita is 0.4 zeros and then a 447. So now it says change that to per 10,000, which simply means multiply your per capita by 10,000. For per 100,000, we're going to multiply the per capita by 100,000. And for per 1 million, we're going to take that per capita and multiply by 1,000,000. And when you do that, you see we have 0.447. So that means for every 10,000 people in Indiana, there are 0.447 school districts. That's what that means. For every 100,000 people, there are 4.47 school districts, and for every million, there's 44.7. So which of the above options is the appropriate scale? Well, generally, you want something that's going to be the easiest to kind of think through and logic with. The bigger the number here, the harder it is for really to understand. I have no comprehension of what 1,000,000 people looks like. But I know what 100,000 people looks like because I can think of a football stadium, Ohio State, Michigan. Those football stadiums hold about 100,000 people. So I have an idea of what 100,000 people look like. So for 100,000 people, there are 4.47 school districts. So you always want to kind of keep it the smallest per that you can while still having a non-zero number in the front. That's kind of your goal when you're thinking about scaling up. So which state has the most school districts per capita and which one has the least? Well, let's go back to our graph. The most, we'll look at the last column. The biggest number is Illinois. So they have the most because they're at 6.66 times 10 to the negative fifth. Whereas the least is here, 3.93. So the least is Kentucky because 3.93 is the smallest number. All right. So that was Illinois and Kentucky. All right, 2 proportions and we'll call it a day. If 14 bags of mulch cost $51.10, how much would 49 bags of mulch cost? So we're talking about bags compared to money. So 14 costs $51.10, 49 costs X. Cross multiply, divide. 49 bags would cost $178.85. To determine the number of fish in a popular fishing lake, conservation officers catch and tag 200 fish, throwing them back in the lake. Weeks later, they catch 82 fish and discover 8 are tagged. Use proportional reasoning. Okay, so we're talking about tagged fish to total caught. Okay, well, think about that first time. You caught and you tagged 200 fish. Out of how many? Well, I don't know. I don't know how many fish are in the lake, but the 200, I tagged them all. Then later, we caught 82 fish, but only 8 were tagged. So 8 out of 82, compare that to the 200 out of all of the fish in the lake. So then when I cross multiply, it leaves me with roughly 2,050 total fish, assuming this is proportional, tagged to total. And there's your practice page for section 3.